Okay, so let's do this last problem in the notes. So this is called a complex fraction because complex fractions have fractions inside of fractions. So whatever you have a complex fraction, it's important to understand that the big fraction bar, which is this one in this case, acts like a grouping symbol. I'll sometimes put dots on the end of my bar just so I can tell which one's the big one. So since that's a grouping symbol, we have to do this stuff on the numerator and the denominator separately first before we put them together as a division problem. So we're going to subtract these. And the common denominator between those two is x minus 2. So and then when I subtract those, I get that. So that's going to be the top of my fraction. Divided by, and now I'm going to do the bottom of my fraction. So the common denominator there is x plus 3. And then I can combine those. Looks like that. So now what I have is this. And now I'm ready to do the same switch flip thing. So keep the first fraction the same. Switch to a multiplication. Flip the second fraction. Now, if I could simplify anything here, I would. I'd go ahead and do it. I'd like factoring the top just to see if anything works out. Factoring the bottom. And notice this time, nothing actually cancels. So what I'm left with is just what I get when I multiply the top times the top and the bottom times the bottom. And then my domain restrictions can't be 2, can't be negative 3. And I would check back here, still can't be 2 on either one of those. There you go.